Hi guys. So this is a last special function that they talk about in that section, that 2.2 that we've been on forever. And it's called the piecewise function. And in the textbook, what they want you to take a look and understand is that the absolute value function right here is actually, I'm going to put arrows here, is you could be classified as a piecewise function because it's made up of f of x equals y equals equals x, sorry, or negative x. Ouch. Sorry. Okay. And so this part is the f of x equals x, and that right there is f of x equals negative x. And so I have to split up the domains. Okay, I have to split up the domains, and so from here, I'm going to include that 0 as part of the one on top. You don't have to. X is greater than or equal to 0. And I can't put x is less than or equal to 0. That would make it not a function anymore. That would be a quiz question. Is this a function? And have both of those inequalities have it equal. And it would be no, because look, it overlaps. It maps twice when x equals 0. Okay? Well, it's part of two different functions. Is it really? I'm not sure. But to me, that would sound like, that would be like, hey, over here for this one, if it was equal to, it would be 0, 0 here, and it would be 0, 0 here. But it's the same point. So would it still be a function? I had to stop the video actually and really think about that one. Okay? Because what you're doing is taking this graph right here, and this point would be the same, and then you're just putting it on top of each other. So this would not be a function. You have to exclude the equal sign from one of them. Okay? So once again, okay, that's why I don't have an equal sign for both of them. It would not make it function because that 0 overlaps. Okay? To give you an example like this, consider the function f of x. We have a linear x minus 4 when x is greater than or equal to 3. And then we have a quadratic negative times x minus 2 squared when x is less than 3. First, it wants you to find, hey, this is pretty easy. F of negative 1, f of negative 1, f of negative 1. We have to figure out which one to use. We have to use that one because it's less than 3. We have to use a quadratic. So negative 1 minus 2 squared equals negative 1. Negative 3 squared, which is negative 9. F of 0, once again, we have to use the quadratic. 0 minus 2 squared equals negative 2 squared equals negative 4. And then 3 and 5, we have to use the linear. F of 3 equals, so we have 3 minus 4 equals negative 1. F of 5 equals 5 minus 4, which equals 1. So we have 4 points. Now we have to sketch it. We have to sketch it on this graph right here. We've got 2 linear points and 2 quadratic points. Okay, we have -1 and 9. I'm going to rewrite this. This is -1 and -9. This is 0 and -4. This is 3 and -1. And this is 5 and 1. So -1 and -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ba-bam. And then 0, 1, 2, 3, 4. Ba-bam. And then 1, 2, 3, 1, 2, 3, -1, ba-bam, 1, 2, 3, 4, 5, and 1, ba-bam. So these are my linear. And it looks like the x-intercept for the linear function, this one, is going to be, let y equal to 0. So 0 equals x minus 4. And that means that x equals 4, right? 1, 2, 3, 4. Kind of like there. So that's my. And then when you look at this quadratic right here, y equals -x minus 2 squared. You know that the vertex is going to be 2, 0. 2 and then plus 0. So 2, 0, 0. And then it reflects over the x-axis, so it's going to look like this. Now, what the textbook doesn't kind of go over about piecewise functions is that you got to look at that overlapping area, point, which is right here, where they overlap, which is going to be 3. It's defined here. We've already defined it right here. For the linear function, we know where it is. But we don't know if that actually connects. We can assume, we can connect these two lines right here. We could connect these two things to make it go together. But we don't know. We have to actually put in f of x, f of 3 into the quadratic, even though it's not part of that domain, okay? A stated domain. I keep on making really crazy hand gestures like I'm teaching this in class, okay? So that you know where that point is, okay? And I'll show you examples where you see something really crazy going on. And this is why you need to figure that out, okay? So we have this and ba 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 bam bam. Sorry, I have a tendency to sing. Okay, and then that becomes 1, -1. So it is the right point. It does overlap. It starts at the same place, right? Right here and right here. So you know that you can connect them together and you are pretty good to go. And so this is the start of the parabola right here. That's the start of the parabola right there. And this part is the parabola. And the other part is the linear function, including that point. Okay? Let's go ahead and remove that red line because it's all a part of one point. Okay, let's do the next one. Oh no, we have not finished. Write down the domain and range. C. Domain. What's the domain? All real numbers. Yes. Linear function domain, all real numbers. Quadratic function domain, all real numbers. They kind of don't have any gaps. They keep on going. You could tell by the inequalities that define their individual domains. Okay? The range. Looking at the graph, look at the range. Okay? There is no spots that are missing. It's going to be all real numbers. Oh no. get sometimes too quick in doing this, and then I write all real numbers. Okay. Next one. Now let's go ahead and graph this. Okay. If I were to say, hey, graph this. First, what I'm going to do is I'm going to start with the leftmost because I just want to. I want to start my graph from leftmost. So I'm going to find some points, and I want to look at especially where it equals right here. Okay, so let's go ahead and do, f of -2. And so that is a -2 minus 1, which is 1. So it's -2, 1, -2, 1. Right there. And I like to graph as I go. I'm going to, you look at the slope of this. Okay, so that's up 1 to the left 1, up 1 to the left 1, up 1 to the left 1. Right. There we go. Okay, now even though the next one is a quadratic, even though it doesn't have an equal to, I am going to check to see where f of -2 is on this quadratic, because I want to see if it starts at that point. If it doesn't, then you're going to have a different starting point. So I'm going to check -2 squared plus 1, which is 4, -4 plus 1, which is a -3. What you notice is it's a different starting point. Okay, it's a different starting point. So how do you graph that? It's -2, 1, 2, 1, 2, 3 right here. It's right here. -2, 1. Is it 1? -4. Is that right? Okay. So what am I supposed to do? I'm just supposed to draw a blank circle right there. Okay. Because that's what you saw on my domain and range worksheet. Is sometimes you see these solid circles. It indicates the start of the graph, but it doesn't actually, is not part of the graph, that point. So you're going to put -2, -3. And then you notice that this quadratic right there just went up 1 from the vertex, and it reflected over the x-axis. And so the slope is going to be -1, so it's going to be right 1 down 1, right 1 down 1. It's going to be right 2 down 4, 1, 2, 4, right 2 down 4. And that's the counting method that I introduced you guys to. If you are interested in the counting method, maybe I'll make a video out of that too. Why not? I don't think I have one because that's a newly learned thing that after I taught Algebra 2. Okay. And then to 1, right? Whoops. I overstepped my bounds right here. Right here to 1. And we're going to put a closed circle right there. Okay. And then let's go ahead and try this linear function right here. We have to test if it starts at the same place we left off on the parabola, right there. We have to test that. So that's x equals 1. So f of 1, where is it? on that linear function, 2x minus 2. So 2 minus 2 is 0. And it starts exactly there. Okay, it's at 1, 0. Exactly there. So we are good. And we just have to go from that point, use the slope right here, go up 2, 1, 2, go right 1, up 2, right 1. Hopefully you remember slope, right? You have to know slope forever. Like forever. Forever. Okay. Wow, look at that. That is my piecewise function. Okay, so let's go ahead and find the domain of this. What's the domain? All real numbers, right? X, all real numbers. Set of X such that X is all real numbers. Now, let's go ahead and find the range. The range is where? Starts where? Y such that it starts right here at this open circle. And I know the textbook is showing you like the brackets, and that's interval notation, and then they do these brackets like that. Those brackets just mean parentheses, and that's just the brackets that we use. It's the same thing, just they have 1 million ways of writing the same thing, but once again, you guys should be aware of it. Okay, so it starts at, what is this, 1, 2, 3, -3. So I'm going to first write it in interval notation because that helps me out. I'm just used to writing things in interval notation. So it starts at -3 and it reaches here, it duplicates here, and it goes to positive infinity. So that means that y is just greater than -3. This is negative infinity to infinity. Or the new way, which would be, is it like this? This is brand new. I -3 to infinity. That is something like science fiction for me. So I want you to at least appreciate the fact that I mean, I know parts of this math book that you don't either. That, yeah, we were in this boat together. Okay, good job, guys. Next, let's go ahead and try to find the equation of this. Okay, I'm going to do this step by step. Step by step. Okay, so f of x, and it looks like we have one. That looks like a parabola. We have 2 linear functions and 1 parabola. Okay, I always like to start on the left side. Let's just pretend that these go on forever. Okay, let's just like to pretend that these go on forever. So right here we have, let's go ahead and make our set. Okay, and then it starts, and these are easiest if you find a good point, which is right there. It's not part of that, but we can count. And then here's another point right here. And so that is going to be 2 points. We have -2 and -1. And what is that one? -4 and 2. Okay. What's the slope of this? Up 1, 2, 3, and to the left 2. Okay, so the slope of this is -3/2. Right? Okay, so we have to just find the y-intercept. Okay, so I'm just going to put it in slope-intercept form, mx plus b, remember that. And I'm going to use one of the points. I'm going to use the first one, and -3/2. Use the x plus b. Well, wasn't it nice when we did linear functions? Do you remember -1 equals -3 plus b, and b equals +3 plus 3, 2, right? So that's a, oh wow, that's a plus. Sorry guys. Yeah, you're not here to check my work. B equals -4. Yes, my little angel in 4B, my little, yes, gift in 4B that checks all my work. Thank you. Okay, so let's go ahead and, yes, shout out to Hasini. Yes, for checking all my work. Why not? Okay, so let's go ahead and create that. So we have -3/2 x minus 4. And then we have to determine where to where, right? So this is when x is less than -2. And then I kind of want to skip the quadratic, if you know what I mean. But this is an easy quadratic. So here's the vertex. So it's going to be x squared. We went up 1, right 1, up 1, right 1. And then you can see that we went up 2, left 2, and up 1, 2, 3, 4. So it's just a parent function quadratic. Yay! Easy. Okay. Nothing happened to it. Went left 1, up 1, right 1, up 1, left 2, up 4. No need to have a multiplier. Okay, so let's go ahead and figure out where to where. Okay, so we see this little dot right here. So it's going to start at -2, and -2 is less than or equal to x. X is greater than or equal to -2, right? X is greater than or negative, and it's less than 1. Now, this is a shared point by this linear function, so you could make it equal into one of them. Okay, so since I gave that equal sign to, since I put the equal sign here, I'll give it to this linear function right here. Why not? Okay, and then let's go ahead and figure out this line right here. You see 1, 1, and 2, 2. Nice slope there. X. And if I go down 1 to the left 1, ha! It's gonna have a y-intercept of 0. Yes, it's just the parent function. Okay, and we know that x has to be greater than or equal to 1. Right? Because remember, we were going to give that one, that x equals 1 to this linear function. There you go. Easy. Piecewise functions are fun. Yes, they are. Okay, next. Here we go. Let's do this one. We have 3 y equals, and then let's see, or f of x equals. I work on problems and then I have thoughts in my head that come in. I don't know why. But I think of other things. I've got so many things on my mind right now. Like chaperoning you guys to the Perot Museum on Monday, which, I don't want to. Okay, so let's go ahead and take a look at this problem right here. Let's go put some arrows because, you know. Oh, should we have stated the domain and range of this? Nah. I'll make that in the next video when I go over the problems that you're supposed to solve. Okay, so let's go ahead and figure out this line right here. It's a horizontal line, so y equals that number 2. Y equals 2 when x is less than -2. We have a parabola. This parabola reflected over the x-axis. It looks like it went up to right or left movement didn't happen, and then it just down 1 to the right 1, down 1 to the left 1, down or right 2, and then down 1, 2, 3, 4. So that one is just the parent. It's pretty much like the parent function, except I mean, not the parent function, but it didn't have any vertical or horizontal stretches or didn't have any multipliers. Okay, so let's just go ahead and check that. Left 2, down, and then up 2, 1, 2, left 2, down 1, 2, 3, 4. Okay, now this one, that x equals 2 is part of it, so we're going to x equals -2 is a part of it. So x, and that, a greedy little parabola, taking all those x values. 1, so x has to be between, and then this is a linear function, and let's go ahead and figure the points out. That's down 1 to the left 1, down 1 to the right 1, so the slope is going to be a negative slope, and if I continue that pattern, up 1 to 1, up 1, that's going to be a -1, and that is from x is greater than 1. I think that's right. I hope that's right. Yeah, I mean, making piecewise functions is not it's easy once you get the hang of it. Okay, I always start from the left side. I hope this made sense. Until we see again. Okay, do your practice. And if it becomes homework, then do it for homework. Okay? Well, bye guys.